All right, so we have developed as a fetus, we have blood flow going, everything's good, now it's time for birth. So the following are factors that contribute to the labor process. It says as birth approaches, progesterone levels are going to decrease. So that was what was maintaining the inner lining of the uterus, the endometrium. We're done developing, so that doesn't have to stay up as much anymore. Prostaglandins are synthesized, which may initiate labor. If you remember from the reproductive chapter, we said that prostaglandins were found in semen, and when they are introduced to the female reproductive system, they cause the smooth muscle of the female reproductive system to contract. So this is obviously not coming from semen, but the prostaglandins do the same thing. They're produced from the woman's body, and they can cause the muscles to contract. Stretching the uterine tissue stimulates the release of oxytocin from the posterior pituitary. So remember, that was one of our hormones in the endocrine system, was oxytocin. So released from the posterior pituitary. And oxytocin, its function as a hormone is to stimulate uterine contraction. So it's going to cause the uterus to start contracting. All right. Remember the position of the fetus that we talked about a few slides ago. So if the uterus starts to contract, that's going to push the head of the fetus closer to the cervix. All right, the fetal head stretches the uterus even further, and then it says positive feedback results in stronger and stronger contractions and a greater release of oxytocin. Remember, positive feedback is when we go further and further away from the normal range. We said that with blood clotting. Your blood should usually be very liquid, but it becomes thicker and thicker. We said sexual stimulation. You should not usually be stimulated, but the stimulation gets stronger and stronger. So in this case, your uterus should not be contracting, but as the fetal head stretches the uterus, your body responds by producing more oxytocin, which causes stronger contractions, which causes the head to stretch the uterus even further, so it just continues to build up greater and greater. And we can see that right here. Positive feedback mechanism propels the birth process. So start up top. The fetal head is forced towards the cervix. This means that the cervix is stretched. Stretch receptors are stimulated. Now, you could add a box right here. They skipped this, but this is actually a pretty important point. So what I would do, if you've got this printed off, right where that star is right there, write down oxytocin is released. And if you wanted a reminder, you might put oxytocin is released from posterior pituitary. Just make sure you know where that hormone is produced. It's released and it's actually produced in the hypothalamus, but what you would need to know is that it's released from the posterior pituitary. So stretch receptors are stimulated, oxytocin is released from the posterior pituitary, reflex is elicited that causes a stronger uterine contraction. The fetus is forced downward. That forces the head towards the cervix. That causes the cervix to be stretched even more. The stretch receptors are stimulated even more. They're going to release more oxytocin, and this just continues, so the contractions get stronger and stronger until delivery is complete. All right? So again, key word there is that this is positive feedback. We've got a few examples. I mentioned most of them earlier, but you can write down birth process. I would write down your positive feedbacks. Birth process, blood clotting, sexual stimulation, and then another one that we're going to look at shortly is milk production. So those are all positive feedback. So there's our stages in birth. A, right here, it says fetal position before labor. So this is just the position of a full-term fetus before contractions have happened. B is dilation of the cervix. So we've started to contract a little bit. That pushes the head further towards the opening, towards the cervix, and that means that the cervix is going to dilate, which means that it opens up even more. Now in this process, if you can see, it says ruptured amniotic sac. So this would be like when the fluid breaks. When the amniotic sac is ruptured, all of the amniotic fluid on the inside can exit the body. It doesn't always happen, but it can happen before pregnancy or before labor. All right, C, expulsion of the fetus. Those contractions continue stronger and stronger. The fetus is going to be expelled through the vaginal canal. Remember, one of the functions of estrogen and progesterone was increasing the female reproductive organs. So the vagina is getting larger to help accommodate the size of the fetus as it is expelled. If you'll notice too, the head is shaped kind of funny, and that's actually on purpose. Go back to the skeletal system back in Anatomy 1, and you might remember that when you're born, all of those skull bones aren't completely fused yet. You have a lot of soft spots called fontanelles. That allows the skull to be a little bit more flexible. It's because that skull, even though everything is enlarged a little bit and the ligaments are relaxed, it still has to go through a pretty small space. So it helps the skull to be a little bit flexible. Those bones aren't tough and rigid. They can actually flex and bend a little bit. It's also why sometimes newborns have heads that are kind of cone-shaped, is because those bones, the skull bones, have kind of been compressed towards each other, and it takes a while for the skull bones to kind of go back to their original shape. So that was C. And then D is expulsion of the placenta. So we've talked about the function of the placenta. It also leaves the uterus after labor. This is where it gets its name. If you've ever heard afterbirth before, sometimes it's called the afterbirth, because after it's done doing its job, after the newborn is delivered, it's delivered afterwards. All right? Okay, milk production and secretion. This one's kind of neat. So the placental estrogens and progesterone stimulates further breast development. So this is what's going to happen during pregnancy. Estrogen and progesterone levels have been in the body of a female since puberty at pretty elevated levels, and that caused breasts to be developed in the first place at puberty. But then when those levels go much higher, that's going to cause further development of the breast. And it really does develop the breast. So the breast can almost double in size, or sometimes they can double in size during pregnancy. The reason is we're going to be building a lot of ducts, a lot of ductile tissue, and the glands that are going to allow the female to start to produce milk after birth. Estrogens cause the ductile system to grow, and progesterones cause alveolar glands to develop. All right? So estrogen makes the ducts that are going to take the milk from the glands to the areola, and the progesterone causes the glands to develop in the first place. Alveolar glands, those are just the names of the milk glands. So they're these kind of bulb-shaped glands where milk is going to be produced on the inside, and then that milk is going to be expelled from the glands through the ducts to the areola, to the nipple. Okay, placental lactogen also produces changes in the breast. And prolactin, this is our milk-producing hormone. If you remember flat peg, which was the anterior pituitary hormones, P stood for prolactin. Prolactin is released about the 5th week of pregnancy. Now, here's where it gets a little tricky, is that prolactin should be producing milk. So you would think that after 5 weeks, the pregnant woman is starting to produce milk. However, it says milk production and secretion do not begin until after birth. The reason is prolactin is there, it's being produced, but it's, and that should probably say prolactin is produced instead of released. But prolactin is produced after the 5th week. However, placental lactogen, scratch all that. Prolactin is released. But there's that placental lactogen that we talked about up here. It actually blocks the actions of prolactin. So even though prolactin, which is the milk-producing hormone, is being released, the placental lactogen is blocking its actions. So the mammary glands are developing. We're getting all of the ducts to form. We're getting all of the glands to form. But even though prolactin is being released, that placental lactogen is blocking the actions of prolactin. Okay? Might be a good time to review these hormones because it's been a little while. So you could just write down, again, pretty good note card material. You can put hormones of milk production and then write down estrogen causes ductile system to grow. Progesterone causes glands, alveolar glands to develop. Placental lactogen produces changes. Prolactin, even though it doesn't say this, prolactin is the milk-producing hormone. Just make sure you know that that placental lactogen blocks the actions of prolactin until after birth. So last bullet, and I've said this already, milk production and secretion does not begin until after birth. So even though I've got prolactin, or not me obviously, but even though a pregnant woman would have prolactin in her body, it's not going to produce its effect, which is to make milk, until after birth. All right, we can see some pretty drastic changes in these pictures on the left. This is from, these are both pictures of mammary glands in a non-lactating female. You can see these purple circles, that's the glandular tissue, so this is where milk would be produced. Now, woman is not lactating in this case, so they're there, but they're not really active. Jump over to the right side. These are the glandular tissue of a lactating female. And you can see those glands are much, much bigger. There's a lot more of them, and there's a lot of substances being produced on the inside. Okay, so what you can do above the right picture, you could just write down non-lactating female, or this would be the left. Non-lactating female would be right here. And then on the right side, where those glands are much, much larger, that would be lactating female. You could write those notes right there, just to make sure you know the point of this picture. All right, we also have myoepithelial cells that will contract to release milk from the alveolar glands. So around those glands, you can't see, but there's a really, really small muscle layer called myoepithelial cells. Okay, myo means muscle. I know we've used that word a lot in here, but definitely in Anatomy 1 in the muscular system, you saw myo a ton. So myoepithelial cells are muscles that will contract. And when those muscles contract, that means that milk is going to be released from the glands. All right, so mechanism of milk release. This is after birth has taken place. Prolactin, again, is an anterior pituitary hormone, and it's responsible for milk production. Okay, so that's going to cause the milk to be produced. These are the alveolar glands that we mentioned earlier. So this is the milk glands. The milk is being secreted. Oxytocin causes contractions of the myoepithelial cells and the expulsion of milk. So we can see the glands on the inside are producing milk. That's due to prolactin. The myoepithelial cells surround those glands, and they're going to contract due to oxytocin. Just like oxytocin caused the uterus to contract, it's also going to cause the muscles of the glands, the milk glands or the mammary glands, to contract. All right. Now, if you ever heard of a letdown reflex, this is really interesting. It's really neat. So what happens is that for a woman who is lactating, the sound or sight of a baby, and sometimes that can increase milk production. And write down right here, I want you to write down and expulsion. Okay, the sight or sound of a baby can increase milk production and expulsion. All right, so and I said this is neat, so let me explain what it is if you're not familiar. So the evolutionary reason that this would happen, and this happens with other animals too, is that for other animals when they live in packs, or if you think about humans when we lived in tribes where there were several family groups that were all in the same area, typically the men would go out and the women would take care of the kids. All right. So the theory of why this would be helpful is when you are a mother, if you're lactating and you've got all these children that you're watching after, and most of them are probably not your child. Let's say that child's mother is gone. She's not there for some reason, and they're hungry. When children are hungry, they start to cry. That crying, especially, it says sound or sight, but typically the sound that we're talking about is a baby crying. That's going to cause the lactating mother, even if it's not that crying child's mother, it's going to cause them to produce milk, and milk is going to expel. So that way, if you live in a group, whether the child's mother is there or not, you have mothers that are producing milk that can feed that child. Socially, that sounds kind of strange to us, but there's nothing like health-wise wrong with that. That's actually pretty good. If a child is being nourished by several different mothers, you're getting a lot of different antigens from the milk, so that could actually make the child even healthier if that happened. It's just we don't typically do that. But that's the reason that letdown reflex was developed, is what we think, is that a child is crying, and if there's any mother that is lactating, then she could feed that child. Now, I keep saying that's neat. I've never been a lactating mother, so I'm sure if you're walking down Walmart or the mall and there's a kid crying a couple aisles over, and all of a sudden you start excreting milk, which that can happen due to a letdown reflex, I'm sure that that's not very comfortable, but that can occur. Another thing the letdown reflex has to do is when the nipples are stimulated, that causes the release of oxytocin too. So the reason that would be important is when a child is suckling, that's going to stimulate the nipples, and that causes oxytocin to be released, which causes the milk to be expelled, which is in response to the child suckling on the nipples. All right, so that's milk production. There's a control of the hormones, so you can go through and read those, but we'll finish up with the next part after this.